Let's see how to build NMOS diode connected PMOS common source amplifier. So here, instead of the resistor, we are using the NMOS diode connected. So for this one, okay, I'm going to create a new project, and here I need to add a component. That is, first of all, we need to create a PMOS common source amplifier. So PMOS, and here I have this PMOS port, that's the monolithic IC or the monolithic PMOS, and I need to give the two voltage supplies. That is, first one is the Vin. So that's our input voltage, and we even need to give the VDS. Okay, these two are the VDS and the VGS. So since it's a PMOS, this is a source and this is a gate and this is a drain and this is the base. So we need to connect this gate to the input source, and this has to be negative. So we just give the sine wave here. So I'm just going to the sine wave and DC offset, let's say minus 0.8 volt and amplitude of 1 millivolt, and even the frequency of 2k. So this has to be negative because whenever it is negative, here the electrons will come and it will going to attract the holes to this channel, so the current flow increases. That's why it's called as the p channel, that is the PMOS. So now we have a resistor here. In our usual PMOS common source amplifier, we have a resistor here. Okay, let's move this command little bit side. So we need to replace this resistor with the NMOS diode connected. So okay, let's connect the remaining things. So we need to connect from here to here, and even I need to connect this from here to here, and even okay, so it's connected now. And this one, always remember, this has to be, base has to be connected to the source. So and this, the above one is the source. Okay, so we need to connect this to the above, because in this PMOS, this the source drain and this is the gate. Okay, now we constructed, okay, I forgot to add the ground. Here is ground and these two has to be connected, because this is a VGS, that's why it is gate and the another terminal is the source. So this is the source, so this we need to even ground, or you can just connect from here to this terminal. Okay, that's it. Now we constructed our basic common source PMOS amplifier, and we need to define the model. So for that one, I'm just going here dot model and PMOS, and here kp equals to 200 micro and VTO equals to minus 0.6. So this is for the PMOS. Okay, we will just keep it here. So now we need to replace this. Okay, let's run this for a and we need to just check the simulation. So 10 amp and this is 0 and this is bit 10. Okay, so cannot definition of the model R. Okay, something it is giving missing the register value. Okay, we just missed this register value. We just need to give this as a 2k, let it be 2k. Okay, now we will run the circuit, and again it's giving unknown parameter V. Okay, I forgot to give even this the voltage, that's the VDS. So this will just give as a 1.8 volt. Now if we run this circuit, and this is a simple common source PMOS amplifier, and we need to just look at the output here. Okay, some output we are getting, and we even forgot to set the length and the width of this MOSFET. Let's see, this is length and the width. So now if we run the circuit, we are getting around 1 volt to the, there is no much gain. Okay, so okay, let it be like that. Our main intention is to change this resistor, replace this resistor with a NMOS diode connected. So we just need to cut this resistor, and in this place we need to add the NMOS diode connected one. So this is our NMOS, and here, okay, I'm connecting like this, and this is my base. Okay, this has to be connected to source. In NMOS, always remember its drain is the above and the gate and the source. So this I just need to connect to. Okay, I just missed it. I just need to connect this base to the. Okay, we will connect it from this base to the source. Okay, and in diode connected, this one, that is the gate terminal, that has to be connected to the drain. So I need to connect this to here. So okay, this is now diode connected NMOS, and I need to connect even from here to here to complete the circuit. Okay, now we just have to give this as a 1U, and let's say 100U length and the width of this NMOS. So now let's run the circuit, and we want to see the output here. Okay, so yeah, we are seeing the output here. Now let's play with these values. So we need to maintain both these transistors in the saturation region. So let's say this will be 0.7, and we'll check it now. So and okay, so 0.10 we just changed. Okay, I just forgot to add even the dot model for this NMOS. So we'll just copy the same thing, and we need to go to the spice directives, and here instead of the PMOS we just need to make this as a NMOS, and here this has to be 0.4. Okay, let's have it here. So now let's see, and this is from 1.3 to 1.301. The gain is very less, so there is no gain at all. So we need to change this, and we need to see. So I will just make this as a 0.44. So okay, now no, it is not. We just need to increase the tolerance of this sine wave, because we are not getting the proper sine wave in the input side. We'll just check it to this one. Yes, we are getting. Then we need to increase this, because it is the less than minus 0.6. We need to just make this as a greater than minus 0.6. So let's make this as a minus 0.9, and we'll run the circuit, and we need to check the output here. So now it is from 1.1 to 1.09. This time also the gain is less. So let's change this from 1U to 10U, because we need to increase the resistance of this. So now let's see, it is 451.2 to around 448.2. That means so it increased from 450.6 to 448. That means the gain is now 2. So only very small gain. So our signal is 1 millivolt, and here we are getting the 2 millivolt. That means our gain is slightly increased. We need to increase even more. So actually in this circuit we cannot able to get the more gain, these kinds of circuits. So let's check whether we can increase. So let's make this as a 2, no, let it be 1, and this we just reduce from 10 to 8. Then we just see whether we can increase the gain. So 339 to 336. Okay, so now it gets increased from 2 to 2.5, only 336 to 339.5 millivolt. That means only 3.5 millivolt we are getting at the output. So yeah, basically we just replaced these resistor with these NMOS. That means the diode connected NMOS. I think you got to know how to use this diode connected NMOS. So our main intention is to replace this resistor by using some other transistors that's diode connected. So in the more advanced circuit, we can increase even the gain of these circuits. So you can try with these circuits. This is cascaded with the another some like NMOS or the PMOS with the diode connected NMOS or the PMOS. So even this circuit can be cascaded. I think you understood this. Thank you.